Okay, perfect. All right, so I'm going to start off with some documentation that I wrote to briefly go through it, and going to try and show as many technical examples as I can as I kind of walk you through the technologies that we use and how to use them. So to get started, most of you who were there last week probably heard Tycho mentioning Magic Protocol. So Magic Protocol is basically the protocol that we use ahead of SBTC to allow us to kind of have Bitcoin utility in our application. And it's at the moment, I guess personally, the only way that I would build Bitcoin apps at the moment, because it will be very easily translatable into SBTC. And so you'll be kind of ahead of the curve when SBTC comes out. In terms of how it works, Tycho kind of briefly mentioned that already, so I'm not going to bore you with the details, but from a programmer's perspective, what you're really interested in is, I suppose, the smart contracts, how to interact with them and how to use them to interact for your own protocol or your own product, how to use them to make your product interact with the Bitcoin blockchain directly. So the first thing that's really important, and I'm going to take a step back and just give a brief summary of like the 3 different areas of tech that you're going to be focused on when building Bitcoin apps. First thing, obviously, smart contracts, right? So for us to read Bitcoin state, you're going to need to have some kind of understanding of clarity. Ideally, there'll be like one person specialized in smart contracts in your team, or you'll look for some contractors who can do smart contract development, but that will essentially be the core of your product, right? So that is one of the core aspects, but then you also have the front end and the back end. And the front end, you might be familiar with other protocols from EVM, but the front end is usually quite simple. You'll have some wallet package that you use to connect a user to your smart contracts by allowing them to sign transactions with their wallet, transactions of your protocol with their wallet. And it's very similar on Stacks and Bitcoin. I will show you the wallet package that we use personally in Zest and kind of how to integrate that and how to call some contracts. So that's the front end part. And then the last thing is the back end. And that normally gets quite complicated, especially when you're developing on cross-chain protocols, which is, I suppose, what we are and what Bitcoin protocols are at the moment, because we interact with both the Bitcoin chain and the Stacks chain, and we are doing transfers from the Bitcoin chain into the Stacks chain, so that then we can do all kinds of smart contracts on the Stack chain with the locked Bitcoin. So those are the main areas of focus here that I'm going to talk about today. And to start off with, we'll talk about the contracts. And that being said, the most important contracts for you to right now develop something or a protocol where you use Bitcoin in your app, the most important protocol is the Magic Protocol. So without further ado, I will just show you a little bit of the contracts that we have on Magic Protocol. So you can find the Magic Protocol contracts themselves in the Magic Protocol repo. We have on GitHub, Magic STX is the username, and Magic Protocol is the repo. The main contract for Magic, which we're looking at, is the bridge contract. And so I had that open here, but I've made some more concise notes. And in the bridge contract, you're really interested in some main contract calls, which are to do with the escrow swap that Tycho mentioned last time. So you're going to be wanting to swap Bitcoin for XBTC, and then using that XBTC within your protocol to do whatever you want to do with it, whether that is, generate yield like we do or something else, completely up to you. But that's the main mechanism with which you transfer Bitcoin into your protocol. And so I will also link these documents later, so that if you feel like you missed something or you want me to go through something again, you should be able to go through it later, because there's quite a lot of stuff that I've put here. But just in the interest of time, I will talk about the inbound and outbound swaps. And the inbound and outbound swaps, you will find the actual code in this bridge.clar. I mean, if you look for inbound swap, there's loads of, well, there's too many there, but what I'll do is here, I'll just look for the, I think it's on the next page. Yeah, so the escrow swap is the swap where you are putting the Bitcoin in and changing it to XBTC. And in general, you can call these contracts directly that you see here in the bridge.clar. Just excuse me, but I forgot how huge this file was, so probably best not to use that as reference. But the arguments and everything you can find here. The point is, if you want to create something specific and bespoke in your protocol where you're doing the swapping, and the swapping is somehow stored in on the blockchain, on the Stacks chain, and you're storing information about the swapper, and you are swapping the Bitcoin in a way where you want the XBTC to go directly into your protocol. So whether that's into a vault, into a pool, into any kind of entity that can hold funds, it's entirely up to you. But you ideally want to create a wrapper contract. And so at Zest, what we created was a wrapper contract where we create Stacks contracts from within where we call the Magic Protocol escrow swap contract. However, after that, we map information from the swap into our own contracts, and then it's stored on chain so that we can kind of monitor and store data with regards to the swapper and what they're doing. Here in the documentation that I've provided, I've kind of made a little guide on how to do this effectively. But the most important thing is when you are swapping in or out, you want to have two calls, ideally. One is to initialize a swap and one is to finalize a swap. And right, here is the inbound swap and the outbound swap. With regards to what you'd like to store or what you'd like to do around the swap, that's entirely up to you. But as an example, what we do in Zest is we store information about the swappers who are putting Bitcoin into the escrow swap to warn our backend that we've got a swap coming in, and to store the data, index it, and so that we can kind of display statistics and call a finalized swap contract on behalf of the user. So what that means is that the user just needs to sign one transaction, which is the first call, which is the inbound swap, send funds on our side, and then we get a notification that this is going to happen, and then the user has to go ahead and send Bitcoin to an address that's generated by this contract that we display to them on the screen, and then our backend handles the rest. Why is this important? Well, when you're trying to make a protocol that uses Bitcoin, ideally you want to limit the number of steps that a user has to take, and you want your backend to make as many steps as possible that are absolutely necessary for the swap, but not necessary for the user to sign, right? And so that is where these kind of wrapper functions can come in handy. Is you can create a wrapper function with a specific logic, and you can call it from your backend once this first initialized swap function is called. Yeah, in the interest of time, I just want to say that all this documentation and any issues or questions you have with regards to this, I'll be happy to explain that in a bit more detail. But I've put this thing together for you guys, so hopefully that will make a little bit more sense once you can read it yourself. And with that being said, I want to move on to the front end side. So just to summarize, this first section is about the contracts, and in terms of contracts and how to bring Bitcoin into your protocol, you want to be calling the escrow swaps that are used on Magic Protocol. Now, to make those more custom for your protocol, you want to be wrapping them in wrapper contracts, which are kind of your own contracts that store information about the swapper in your contracts on blockchain, so that you can then use this to call further contracts from your backend, from your stack, and do something with that information. And again, this may sound vague and general, but it's entirely up to you what you want to do with the Bitcoin that comes in. So that's why I've tried to make this as kind of generic as possible. But yeah, happy to clarify on that further if you have any questions later. So that part is done. If we now move to the front end, we use a wallet called a wallet package called MicroStacks. Obviously, by this point, you probably have heard of the Hero wallet or Xverse wallet. And these are two wallets that we primarily use to develop with. But I think at Zest we mostly have used Hero wallets. Entirely up to you which one you want to use. But to integrate the wallets into your front end, you want to use a package like MetaMask, but what we have for Stacks is MicroStacks. So MicroStacks has a pretty well documented website with these starter apps. And I've gone ahead and created one. I've basically used the exact same commands over here, and I've created one ahead of time just to save us a little bit of time, so I can squeeze this in here. And what I have here is the file structure that comes from initializing a MicroStacks project. So basically, if you want to initialize the project really quickly, get started, you just run npx create USDX. This is what I've done. And when I do that, I get this this structure here with all the files. And after installing the dependencies, I can run npm run dev, run it locally. And what I get is this. So this is a testnet network wallet that I've connected here with some testnet STX. And the idea of connecting a contract to the front end is as simple as following the MicroStacks documentation, looking for calling contracts, and copying this code here. Obviously, the code here is like I guess a mock contract, and once you deploy your own contracts, you'll want to change the contract address here, want to change the arguments, names, etc., etc. This is using a fake contract called Faker, but you need to install MicroStacks. You need to import a hook, React hook called use open contract call. What I've done for us is I have created a custom component called contract call, where I've done exactly this, but it has the exact same fake contract here. And I return this, I render a button where I handle the open contract call. And what you should see in this case is when you go to the site that's being run, when you click this button, this is by the way, this is if you go into the actual code here, you go into the app, JSX, I've added my custom component, my contract call TX here under the network toggle button. And when you press it, a pop-up should come up. I'm not sure if you can see it on the screen share. Sometimes it's funky, but I see a pop-up here, and the pop-up has the name of the contract and has some transaction details, etc. And you can confirm the contract call. And then here, well, this custom code that got for the demo that's on the actual microstacks demo just shows the transaction ID and the raw transaction. But what does this effectively mean? Well, you could put your wrapper contract here, whatever your front end is, right? You have people sign out or sign in with their wallet. And once they're signed in with their wallet, their wallet address appears here, much like you'd see when you're signing in on some random protocol. And you can do the contract call just like that, just with a simple click. So taking a step back now, thinking about like what we've spoken about so far, we've got the front end, the UI, and we've got the contracts. So far, basically, by using these resources, you can create a contract that allows someone to send Bitcoin into your protocol and allows them to log in with their Stacks wallet on your website and call the contract with a click of a button to send that Bitcoin into your protocol, right? So far, so good. So now, this is just the front end and the contracts, and we've yet to speak about the back end. I notice now that we have around 10 minutes left, so I'll try and cram as much here as I wanted to. But ideally, the functionality of the back end is to call all possible contracts and steps in the different user stories and flows of your protocol that it can, and make the user experience as seamless as possible for the people who are using your protocol. So to do this, I'm going to show you one of the tools that we're using to build, which is created by Hero. It's called chain hooks. Chain hooks effectively let you trigger logic based on different transactions that happen on chain. So chain hooks, they work both on the Stacks blockchain and the Bitcoin blockchain. If you are building on Bitcoin, obviously it's quite interesting to use the Bitcoin chain hooks, because it means that you are able to change the state of your front end, or change values or log values or index values in your backend based off things that happen on the Bitcoin blockchain. And when we're doing this swap, maybe some of you can already see how this is important. The important part of the escrow swap is when the user has to send the Bitcoin into the address that's generated during the Magic protocol contract calls. And so the chain hook is really good here, because what happens is you can basically spin up a chain hook that listens to transactions on the Bitcoin blockchain, and you can specifically point it to listen to any payments into that address, which is generated for the user to perform their swap. Meaning that once the user has performed their swap, you can run some logic, right? And in this case, what did we want to do? Well, we wanted the Bitcoin to finalize the swap, the backend to finalize the swap. And so what we can do is we can spin up a chain hook that listens for this swap on the Bitcoin chain, or this transfer of funds to the correct address on the Bitcoin chain. And once that's completed, we can run the second step of the swap in our backend without requesting the user to sign that. So we can essentially complete this Bitcoin transfer into the protocol seamlessly for the user using these chain hooks. Now, the chain hooks themselves have been, developed for a while now. When we started working on them, there was barely any documentation. And the current version and the latest version of the chain hooks has incredible documentation. It also has CLI commands that you can use to test the chain hooks, right? And so the main idea behind chain hooks is that you have these things called predicates. Predicates are basically conditions that you're listening for that then trigger the logic that you want to run after the condition is met. So you can have predicates for many different things, and there's many examples here, but you've got some are okay if there is a transaction ID matching a given, if you've got transaction matching a given transaction ID, or if you've got specific characters in some of the fields, if you are sending money to a specific address, et cetera, et cetera. And I guess for us, for this specific case, it's one of the most important predicates would be if funds are being sent to a given recipient, which in this case, our case, it would be the address to which the user wants to send their Bitcoin to complete a swap into our protocol. So this predicate here, as an example, would allow us to do that. You want to remember that there are P2PKH, P2SH, etc., different types of transfers. But for let's say for a basic hackathon where you're doing this, it's quite safe to use the P2PKH to do demos, as you can use Clarinet, which is I guess the dev toolkit for stacks created by Hero to spin up local chains to do a bunch of this testing. I wanted to get a little bit more time on this, but I think there's quite a bit of good documentation, and also you can see some GIFs here and a lot of examples, such how to run the Clarinet chains locally. And yeah, this whole ecosystem for a developer can seem very confusing and very, I guess, all over the place when you start with it. It certainly did to us, but I assure you, if it seems like that now, it was a whole lot worse earlier. And now there's like amazing documentation, loads of improvements, and a lot of dev tooling that's available. And I would highly recommend you to use the Clarinet repo documentation and the Chainhooks repo documentation as your guide into getting these chain hooks into your stack, testing out triggers, testing out logic, and then applying it to your product and your protocol, and combining it to your stack to effectively let people transfer Bitcoin into your product and then do what you want with it using Stack smart contracts. So I think we have 4 minutes left. Maybe I could take some questions now, and then I can just ensure that all the relevant resources and documents that I've spoken about today are included in the pack that's going to be sent to you guys, so that you can start putting things together yourselves.